In this problem we have a lifeguard whose job is to save a drowning child, and since he runs much faster than he swims, the idea is he will run along the beach for X meters, upon which time he will start swimming towards the child, and he will swim Y meters to get there. It is given that the horizontal distance between the lifeguard and the child is 60 meters, and the vertical distance between the lifeguard and the child is 40 meters. It is also given that the lifeguard can run at 3 meters per second and swim at a rate of 1.2 meters per second. The problem is to minimize the time it takes to save the child by finding the exact location on the beach for which the lifeguard would enter the water. In other words, how many meters should he run down the beach? To minimize the amount of time it takes to get to the child, we need to write an equation for the total time it takes to get there. You may recall the equation that distance is equal to rate times time, and since I'm trying to find an equation for the total time, we'll call that t. I'm going to solve this equation for t by simply dividing both sides by r, and for example, we know the distance along the beach would be x, so I replace the letter d with x. We know the rate at which he runs is 3 meters per second, so I will replace r with 3. Let me call that t sub b, b representing the beach. So over here for my total time function, I'm thinking we're going to have two different times. The time it takes him to run along the beach, and then we'll add that to the time it takes him to swim. I'll write t sub s. So where we see t sub b here, I can simply replace it with x over 3. Now to write an equation for t sub s, I let the distance that the lifeguard swims to the child to be y meters according to the diagram, so that would go in for the letter d, and then for the rate, r, we were given that the lifeguard swims 1.2 meters per second. So I'll replace r with 1.2. So we get the total time it takes for the lifeguard to reach the child to be t sub b, which I'm going to replace with x over 3, plus the time it takes to swim, which we just found to be y divided by 1.2. And my job is to minimize t. To do that, I'm going to have to write my equation in terms of a single variable. One way to do this is to find an equation that relates the letters x and y, and then take that and substitute it in for the letter y, and then my time function will simply be a function of x. To find an equation that relates x and y, I'm going to use trigonometry. In my diagram, I'm going to superimpose this right triangle with leg 40 meters and hypotenuse y meters. I can find an equation that relates x and y by expressing this distance along the triangle in terms of x. To do that, remember that the total distance between the lifeguard and the swimmer is 60 meters, but the lifeguard is not going to run the entire 60 meters. It would be some number less than 60, which we denote as x. He's going to run x meters. So if the long length is 60 meters and the short length is x meters, I surmise that this leg of the triangle here would be 60 minus x meters. So let me bring that over here for sake of clarity. This leg was 40. The hypotenuse was the letter y. I can simply use the Pythagorean theorem to find an equation that relates x and y. We know by the Pythagorean theorem that 60 minus x, the length of that side of the triangle, squared, plus 40 squared is equal to y squared. Because I want to take y and substitute it with an expression with x, I will solve this for y by taking the square root, and since this is going to represent distance, I know this is going to be a positive number, so I'm taking what's called the principal root. The principal root is the positive case. I'm ignoring the negative case. So now that I have this equation that relates x and y, I can simply substitute the letter y in my time equation. To find the x value that minimizes the time function, I'm going to use my graphing calculator. I'll press y equals, type in x divided by 3, and since I'm anticipating this entire numerator, that radical being divided by 1.2, I'm going to start by typing plus and then a left parenthesis, and I will type the entire radical in this set of parentheses that I just started. I'm going to press second x squared to get a square root. Make sure you press right parenthesis before you press the square key to make sure the whole expression 60 minus x is being squared. Now that I'm done typing in the numerator of the second fraction, I'm going to press right arrow to get out of that radical and type divide by 1.2, and then I need to set up my window. To set up the window, you have to realize that x represents the distance the lifeguard runs along the beach. Since the horizontal distance to the swimmer was 60 meters, I'm going to say that x can be between 0 and 60 meters. The output is the amount of time it takes to reach the child. I'm going to put my min at 0 seconds. I have no idea how long it's going to take to save the child. Perhaps a minute and a half. I'm just going to say about 100 seconds. Press graph and see what I get. It's a little unfortunate that I chose a window for which the graph looks relatively flat. I could change the window to make this look more like a U-shaped curve, but it's not necessary. I can see that the curve is decreasing, flattens out, and starts to increase. There's a definite minimum somewhere in here. If you press trace and use your arrow keys, you could trace along the curve and get an estimate of how long it's going to take to save the child. If the lifeguard runs somewhere around 40 meters along the beach before swimming, it'll take them about 50 seconds to reach them. But this is not using the full accuracy of the calculator to solve the problem. In fact, I think the problem directed us to round our final answer to 2 decimal places. So to use the full accuracy of the calculator, press second and then the trace key to access the minimum feature of your calculator. Scroll down and press enter on the minimum feature, which is number 3. The calculator wants you to pick a point to the left of the minimum and define that to be a left bound. So simply use the left arrows to trace so that you know that you're to the left of the minimum. It may be helpful to note that you can actually type in your left bound as well. For example, we know that x goes between 0 and 60, so if I was just to press 0, enter, it would define that to be my left bound. As a right bound, you could use the right arrows to move the cursor to the right of the minimum, but again, knowing that my x max was 60, I could just type 60, press enter, and that would define 60 as my right bound. The calculator wants you to guess at what the answer is. You could type in 50. It turns out you can be a bad guesser. Just press enter and make sure that you see the word minimum on your calculator screen. And now we know if the lifeguard runs along the beach 42.54 meters, that'll minimize the amount of time it takes to get to the child. It turns out that time would be about 50.55 seconds. Since the question was, how far along the shore should you run before jumping into the water? That was x. The answer to the question would simply be that x is approximately 42.54 meters. I hope this helps you save your victims.